Welcome everyone. In this lecture, we will study two-dimensional random variables, an important topic in probability and statistics. We will understand joint probability distribution, original distribution, conditional distribution, independence, and solve numerical problems. So let us begin with the two-dimensional random variables types. Until now, we studied the single random variables. In many real-life applications, two variables are observed simultaneously. For example, the height and weight of a person, rainfall and crop yield, or temperature and electricity consumption, etc. Such variables are called two-dimensional random variables. In this session, we will discuss the joint probability function, joint distribution function, marginal probability function, marginal probability function of x and y, and conditional probability function. In definition, the two-dimensional random variable consists of an ordered pairs x, y, where both x and y are random variables defined on the same sample space. The pair describes the outcomes of two related random quantities. If x, y can assume all values in a specified region or in the xy plan, that ordered pair is called the two-dimensional continuous random variables. So next we will see about the probability function of x and y. So for discrete section, it is divided into probability mass function, and for continuous function, it is classified as probability density function. For every case, either we use joint probability mass function or joint probability density function, but the probabilities are always non-negative. And second thing is the summation of all the values, that probability value is always equal to 1, either it is discrete or continuous. So this slide shows the joint probability density functions. So this is for continuous random variables. Here we are taking the continuous values of x and y. So this joint probability density function is given below the two conditions. That is, the function value is always non-negative, that is greater than or equal to 0, and the sum value is always equal to 1. Moreover, that how we can calculate the probability value, that formula is given here. And in particular, if x and y lies between some intervals, so the domain is given here. For x, it varies from a to b. So we have write the lower and upper limit as a to b. For y plane, it varies from c to d. So that integration values lower limit is given in the c to d formula. Next, we will see about the example. So that the function f of x comma y is given here. We have to check it is a joint density function of x and y. First, we have to think, here it is given like that, joint density function. So first we have to check the x and y values. It is not discrete because it lies between some interval. So it is a continuous function. So we have to calculate the joint probability density function. First, we have to check the two conditions. One thing is the function is always non-negative and the summation value is equal to 1. This is the condition. So the given function is noted here. First, we have to check the first condition. And in the second condition, the integration limits we have to first fix it. So x and y lies between 0 and 1. So we have modified it here and solve the problem. This is as usual double integration. So first we have to integrate the function with respect to x and apply the limits. After that we have to integrate the function with respect to y and apply the limits. Finally we get the solution as 1. That is the total probability equal to 1. Therefore our given function satisfies the two conditions. It is a joint density function. Likewise, solve this problem for practice. Here also the function is given and x and y values given. Here look into it, x comma y they are given. That means x also lies between 0 and 1 by 2 and y also lies between 0 and 1 by 2. By calculating integration, use this limits. Okay, here also it is a continuous function. We have to check the joint density function. Finally, here they have told that f of x comma y is a joint density function. They are given. We have to find the k value. So we have to use that second condition to find the k value here. Next, in example 1, 3 problems are drawn at random without replacement from a box containing 2 white, 3 red and 4 black balls. If x denotes the number of white balls drawn and y denotes the number of red balls drawn, find the joint probability distribution of x comma y. First we have to find the solution. Here we have 2 white balls, right? So x can take the values from, suppose we have taken 0 white ball or 1 white ball or 2 white ball. This is the possibility. And why for another case, here we have to take 0 white ball or 1 white ball or 2 white ball or 3 white ball. That is the probability. So here we have to find the joint probability distribution of X and Y. Here X for white ball and Y for red balls. First we have to check probability of X equal to 0, Y equal to 0. That means we have to calculate probability of drawing 3 balls, none of which is white or red. That means what is automatically will come? The 3 balls should be taken as another color black ball. So the formula is denominator. In general, the formula is n of a divided by n of s. So the n of a is we have to take the 3 black balls. That means we have 4 black balls. In that we have to draw 3 black balls. That means combination. So 4C3 divided by this is total probability. Totally we have 9 balls, right? 4 plus 3, 7, 7 plus 2, 9. So 9 balls. In that 9 balls, we have to select either any 3 balls. So it is total probability is 9C3. We have to expand this. Finally, we get 1 by 21. Likewise, we have to proceed for all the balls. For P of X equal to 0 and Y equal to 1 means we have to take 1 red ball and 0 white balls. So that probability is given. Similarly, we have to proceed it for X is equal to 0, 1, 2 and Y is equal to 0, 1, 2, 3 values. Now we are going to calculate the joint probability distribution function of X and Y. This is X values. X is 0, 1, 2. This is Y value 0, 1, 2, 3. Here this table comes from the previous calculations. P of X equal to 0, Y is equal to 0. That value comes in this box. P of X equal to 0 and probability of Y is equal to 1. That value comes in this box. Likewise, we have to fill all the boxes. So finally, we have to add this values, this one, this one, this one, or either this row or this row, this column or this column. Finally, we have to add all these probability values. Final answer should be 1. Please check it. It is 1. Okay. This problem is for your practice. Here it is given like that. A fair coin is tossed 3 times independently. Let X denote the number of heads on the first toss and Y denote the total number of heads. Find the joint probability mass function of X and Y. Here they have denoted it as probability mass function. Mass function means it is a discrete function. So it is not a continuous function. So we have to use the summation formula to calculate this joint probability mass function. Next problem, the joint probability function of 2 discrete random variables X and Y is given by. The function is denoted here, and here X and Y lies between some interval, so it is a continuous function. First, we have to find the constant value, and next we have to find the probability of X equal to 2 and Y equal to 1, and probability of X greater than or equal to 1 and Y less than or equal to 2. For solution, we have to find the sample points X comma Y. So here we have 2, 0, 1, 2 X values and 0, 1, 2, 3 Y values. Totally 3 X values and 4 Y values. So in that X and Y are given, also given that it is a joint probability density function. So we have to substitute in this function. Here X equal to 0 and Y is equal to 0 means we have to substitute in this function. We get the final answer as here also it is 0 plus 0 it is 0. C into 0 is equal to 0. That value is given in this first row and first column place. Likewise, we have to fill this entire table, and this total means we have to add this row, we get answer 6C. Next, we have to add this means 2C plus 3C plus 4C plus 5C, answer 14C. Likewise, we have to fill the last row and last column. Okay, this 42C implies total of 6C plus 14C plus 22C. Likewise, we have to fill. We know that the total probability is always equal to 1. So the total here is 42C equal to 1 means C value is 1 by 42. And for the second question, we have to calculate the probability of X equal to 2 and Y equal to 1. What is X? This is X is equal to 2. and y equal to 1 means this 5c value. So 5c equal to, we know that c value, substitute it here, we get 5 by 42. Next, third question, p of x greater than or equal to 1. X greater than or equal to 1 means 1 is also included here, right? So we have to add all these values, and x is equal to 2 also we have to add all these values. But another condition is y less than or equal to 2 means we have to just focus on this 6 values, that is 2c plus 3c plus 4c plus 4c plus 5c plus 6c. We have to add everything. Finally, we get 24c. Substitute the c value. The final answer is 4 by 7. Thank you.